Alright everyone, this video is just going to be a little introduction to the new topic. I'm trying a different way of recording this. I'm sorry if there's a lot of background noise, hopefully it won't be too bad. So what I'm going to do in this video is I'm actually just going to kind of run through the pages of the booklet that I want you to complete and maybe give you some extra tips, because I don't think there's really a lot in addition to what's in the booklet that I want you to look at. Although obviously if you're ever stuck on any particular section, just try googling keywords or typing some of the keywords into YouTube and you'll often come up with maybe some quite helpful suggestions. Just be aware though that if you are doing that you might see things from, say, the United States or from the English system which might explain things in a slightly different way or use slightly different symbols. Anyway, enough of that. So our second topic in higher chemistry, so it's in the higher chemistry chemical changes in structures unit, and it's topic 2 and it's called structure and bonding. Now I've broken this topic down into quite a few little subtopics, but each subtopic on its own isn't really a terribly big thing. So first of all, this week and just towards the end to the beginning of next week, we're going to cover section 1, which is all about types of chemical bond. A lot of this is a revision from Nat 5, or certainly a lot of the stuff on ionic bonding is. We're then going to look at pure and polar covalent bonding, something called the bonding continuum, and finally polar molecules. This bit about polar molecules I would say is probably the most difficult section, so that's why I'm going to leave that and I'm going to do a separate lesson on that. But we're going to do ionic bonding, pure and polar covalent bonding, and the bonding continuum all in this first lesson. The second part of the topic is a really important one. It's all about intermolecular forces. We've covered London dispersion forces already. That's a recap. And just so you know, intermolecular forces are also known as van der Waals forces. So this part of the topic we will do later on. It's a really important part of the course because it comes up a lot again in Unit 2, which we probably won't do until after Christmas. But that'll be good because that'll give you some good practice of this bit on intermolecular forces. So let's just get started then. Like I say, I'm just going to talk through the different sections of the booklet, try and give you some tips, and if you don't feel like you need these tips, if you think you can answer the questions quite easily already, you might not need to listen to the rest of this video. So, your first page is just a list of the learning outcomes. There's always quite a long list when I get these together, but some of these you'll notice might be things that you know already from Nat 5. You don't need to do anything with this section at the moment. I'll probably guide you towards using these learning outcomes more when we come to do revision if we're preparing for an assessment. So your first page that you're going to begin on is ionic compounds. And this first page is definitely a bit of revision of ionic compounds. So we're just remembering first of all about ions. Atoms can obtain the same electron arrangement as a stable noble gas by either losing or gaining electrons. Now one thing to bear in mind with this is just to remember that metals lose electrons and non-metals gain electrons. So what that means is metals will become positive ions and non-metals will become negative ions. So to fill this table in here, you should be able to use the data book to do this. Even the Nat 5 one will be absolutely fine for this. So you're writing in the electron arrangement for the atom, the electron arrangement for the ion, and then the symbol. Some of them you're only given the electron arrangement for the atom, so you'd have to look in the particular page. I think it's page 6 of the Nat 5 data book. I'm not sure what page it is of the higher, to find that electron arrangement for the atom, and then to work out what element that is all about. So I'll just run through a wee example of this. I think calcium, I'm probably going to get this wrong now. Where's my data book? Calcium is 2882, I did know it. So that's from just straight out of the data book. Remember that the ion, when a metal, calcium is a metal, when it forms an ion, it's going to lose its outer electrons. So the outer electrons is this last number here. And so the ion electron arrangement is just going to be the same as the atom, but without the outer electrons for a metal. So it's just going to be 288. And that's why it's lost 2 electrons. That's why calcium is going to be calcium 2+. A non-metal, so fluorine is 2,7 as the atom, and the ion, when a non-metal forms an ion, it gains an electron. So you're not going to take off any numbers from this, you would just have the ion electron arrangement as 2, 8. So hopefully that'll help you to get this first table started. That's a bit of revision from Nat 5, and I'm sure you can do the symbol for a fluoride ion. Okay, this next little bit is kind of revision, kind of not. To do this section on group ions, what you need to do is look at the data book again, and again it's page 8 of the Nat 5 data book, where you've got this information about the group ions. There's a similar page in the higher one as well, and all you have to do is you have to look at the formula for each ion. So this one is look at the diagram, and you can see in this one there's a sulfur and 4 oxygen atoms. That tells us that the formula for this ion is going to be SO4, and you can see the charge is 2-, so this formula for this ion is SO4 2-, and then you'll need to look in the data book to see the name of that ion. So you'll see that SO4 2- is what we call the sulfate ion. So this is just to illustrate to you that these group ions, we maybe didn't talk about them in that much detail at Nat 5, but these group ions, they look a bit like a molecule. So you've got atoms held together by covalent bonds, but then in order to get a full electron shell or a stable electron arrangement for all atoms, we need some extra electrons in most of these examples. So that's why there's a 2- charge overall. The important thing to remember at higher is that these group ions, something like the sulfate ion, that's only one ion altogether. It contains 1, 2, 3, 4, 5 separate atoms. I suppose you could still call each one of these things atoms, but it's only one ion altogether, so that would be one sulfate ion. So I think you should be able to do the rest of this table reasonably easily. Just make sure you use your data book to get the names of the different ions. And remember, they don't all have a negative charge. Some of them are negative, one of them is positive. Okay, so the next bit again is revision. So you're recapping the formula of ionic compounds, and you have to write, what I've asked you to do is write the ionic formula and the formula for each of these examples. I'm going to post a link to my other video where it reminds you how to write the ionic formula and the formula. Okay, so this is a slightly new bit. We're then going to look at what information is given by the formula. Now, I should have said this at the start. What might be helpful is if you pause the video and then complete each relevant section. So if you haven't completed all the other sections, I would maybe recommend pausing the video and then coming back and watching me go through this little bit here. So what we've got to remember is we've got to remember about the structure of ionic compounds. Ionic compounds do not form molecules, but they form what we call a giant lattice structure. So I've got a picture of this giant lattice structure on the left here. The formula tells us the ratio of the ions in the structure. So in this sodium chloride example, the formula NaCl tells us that sodium and chloride ions are found in a 1-to-1 ratio. So that means that in this structure, for every 1 chloride ion, so the Cl minuses, the negative ones are the chlorides, I'm going to have 1 sodium. So they're found in a 1-to-1 ratio. Whereas the ionic formula tells us the ratio and shows the charges of the ions. So up in question 1 here, the ionic formula shows the charges and tells us the ratio. The formula just tells us the ratio of the ions. So what I want to talk to you about now is the mole and ionic compounds. We have looked at the mole very briefly. You don't need to know a huge amount about the mole, but you do need to know, you need to be able to kind of understand the concept of it at higher. So we've looked at the definition of the mole before, and mostly what we said was one definition of a mole is that a mole of any substance contains Avogadro's number of particles. I also put in brackets when I gave that definition for, we could say formula units as well. So actually I think a better definition of the mole is that 1 mole of a substance contains Avogadro's number of formula units. Now that fits with say a molecular substance, say oxygen is O2, the formula is O2, and a mole of oxygen contains Avogadro's number of O2 molecules. But the key thing about thinking about it in terms of formula units is that it works better for ionic compounds as well. So for example, 1 mole of sodium chloride contains Avogadro's number of NaCl units. So the formula for sodium chloride is NaCl, and 1 mole of sodium chloride contains Avogadro's number of NaCl units, and together these make up the ionic lattice structure. So I'm just going to try and circle the NaCl unit for you. So what we mean by the NaCl unit is we just mean one, because the formula is NaCl, the NaCl unit is just made up of one sodium ion and one chloride ion. If it was, say, calcium chloride, CaCl2, then the formula would be made up, the formula unit would be one calcium ion and two chloride ions. So the formula unit is just, if you picture the structure and just circle the smallest group of atoms that actually makes up the formula, that's the formula unit. Now, this is one thing that gets asked a little bit higher just to check your understanding of the mole. So, because each sodium chloride unit contains one sodium ion and one chloride ion, so we can see that a formula unit contains one of each type of ion. This means that if we have a mole of sodium chloride, this will also contain Avogadro's number of sodium ions and Avogadro's number of chloride ions. Okay, so imagine you can imagine in one unit we've got one of each type of ion. Now just imagine we've got a very big number of these units, Avogadro's number. If we've got Avogadro's number of NaCl units, that means we will also have Avogadro's number of sodium ions and Avogadro's number of chloride ions. So what we can say from that is that if we have 1 mole of sodium chloride, that must also contain a mole of sodium ions and a mole of chloride ions. So I'm going to show you in the next page what type of question comes up on this. I've got a wee analogy here. So again, remember that Avogadro's number is a number unit, a little bit like a dozen, but much bigger. So if you had a dozen eggs, you can see a dozen eggs here, as well as having a dozen eggs, part of those eggs are made up of a dozen shells and a dozen yolks. So if you then had a mole of eggs, so hopefully that makes sense for a dozen, if you had a mole of eggs, you would also then have 1 mole of shells and 1 mole of yolks. So I'm trying to use that to illustrate how if you have a mole of sodium chloride, you must also have a mole of sodium ions and a mole of chloride ions. Just like if you had a dozen sodium chloride units, you would have a dozen sodiums and a dozen chlorides. I hope that's making sense. Just get in touch with me if you're having any issues with that. So here's the type of questions that you'll get asked on that. If I had 1 mole of calcium chloride, CaCl2, how many moles of A calcium ions and B chloride ions would I have? So every calcium chloride unit is made up of 1 calcium and 2 chloride ions. So if we have a mole of calcium chloride, see if you can answer this, pause the video if you want. If I have a mole of calcium chloride, I would have 1 mole of calcium ions and I would also, because each 1 unit contains 2 chloride ions, that means if I have 1 mole, I will have 2 moles of chloride ions. Okay, I hope that makes sense. Your knowledge of this is going to be tested again in question 3 and 4, so try and answer them yourselves. I hope, yeah, just get in touch with me if you've got any more questions on this particular section. I'm going to try and keep this video under 20 minutes, so again, you can pause it, you can skip sections, whatever you want to do. Okay, this last section of ionic compounds is just a little recap then. So go back to your National 5 notes, Google a conductivity of ionic compounds, look at it on bite size, because I think you should be able to answer this one fairly easily. Okay, so just get in touch if you've got any problems with this. So the last section that I'm going to ask you to do is on covalent bonding, and what we're going to talk about in this section is we're going to learn about the impact of electronegativity on covalent bonding. So what I'm actually going to do is I'm going to post a PowerPoint which runs through this in a little bit more detail, but I'm not going to do a voiceover to the PowerPoint because I think it takes things through pretty much step by step if you're able to read what's on the slides. So the last bit for you to do in the notes in this lesson is this bit about covalent bonding. So this question is just drawing dot and cross diagrams. There's a section for you to read through here. Again, all of these questions, you should be able to get the answers from reading this part of the notes and this part of the notes, looking at the PowerPoint, which I'm also going to post, and also using your data book. So you will need to use your data book to get these electronegativity values, which we looked at in the previous topic. So I'm not talking through this in much detail because it's all on the PowerPoint. And again, if you've got any questions on this section, just give me a little email. Right, the final page that I'm going to ask you to do in this lesson is this bit about the bonding continuum. And again, that's all on the PowerPoint and you can read through the notes. Hopefully this will make sense to you. And then you've just got a little bit of extra information in your notes. This final section is about using properties to determine bonding. Now, you need to remember all of your Nat 5 knowledge from this. So you need to remember things like what type of melting, what's the typical melting and boiling point of a covalent network substance. So that would be very high in general. Or you would need to remember, say, that covalent molecular substances tend to have low melting and boiling points. And that's a good indication of the fact that a substance might be covalent molecular. So the main thing to say about this last section is just make sure you revise your properties related to bonding from National 5. You can look that up on Bite Size or email me if you're not sure where to find information on that. And you can also, the other thing I would recommend, is that you memorise one example from this section about a compound that has a different type of structure and bonding than you might predict based on whether the different elements are metals and non-metals. Right, I know I've run through that really quickly. I hope that's made sense. I hope that has helped a little bit. If you were stuck on the notes, please just make sure you email me to get in touch if you have any questions. So we're just doing up to page 8 of the notes for this section.